Let's kick off this explainer with a quote that is as poetic as it is wildly prophetic. Maya Angelou once said, "Someday we'll be able to measure the power of words." Now, what she intuitively grasped as a brilliant writer, computer scientists have literally spent the last few decades trying to turn into cold, hard mathematical reality.
Welcome to our explainer on the evolution of machine empathy. We're going to explore how natural language processing made this massive leap, from just using basic lists of positive and negative words, all the way to advanced context-aware artificial intelligence. We're looking at exactly how computers learn to read human emotion, sentiment, and affect. Because, honestly, this is the entire foundation for how modern machines understand not just what we're saying, but how we actually feel when we're saying it.
We've got a really fascinating journey ahead of us today. We'll be tackling 5 key areas: defining affect and emotion, the emotional dictionary, teaching machines to feel, learning from star ratings, and finally, the nuance of connotation. Let's jump right into Section 1, defining affect and emotion. So before we can even begin to teach a machine to recognize feelings in text, we kind of have to figure out what feelings actually are, which is surprisingly tough to pin down. To make this computational, scientists often lean on the Scherer typology of affective states. In this framework, an emotion is a relatively brief episode of response to a significant event. Think about a sudden flash of anger, a massive spike of joy, or a wave of fear. It's that quick, super intense reaction to something happening right in the moment. But now, contrast that sudden sharp spike with a mood. A mood is what we call a diffuse affective state. It's much lower in intensity, but it sticks around for a relatively long duration, and often there's no obvious trigger. So while an emotion is that quick hit of joy or anger, a mood is more like a long, cheerful morning or a really gloomy, irritable afternoon. And this distinction is absolutely crucial. Computers need to know if they're dealing with a user experiencing momentary frustration or someone expressing a long-term underlying depression.
And then we have interpersonal stance. This basically defines the emotional color that we bring to our specific interactions with other people, ranging anywhere from distant and cold to super warm and supportive. Being able to detect these stances is a total game changer for machines that summarize human-to-human conversations. Just imagine an AI customer service agent trying to figure out if the caller on the other end of the line is feeling friendly or just downright contemptuous.
Moving right along to Section 2, the emotional dictionary.
Okay, so to see how early computer scientists essentially built basic emotional flashcards for these machines, we have to look at affective lexicons. The early models for sentiment analysis relied on simple binary lexicons. Basically, they used massive word lists that just dumped vocabulary into strict positive or negative buckets. But human emotion is definitely not binary, right? So dimensional lexicons came along and completely revolutionized things by mapping words as coordinates in a 3D emotional space. Those 3 dimensions are valence, which is the pleasantness of the word, arousal, representing the level of energy or alertness it provokes, and dominance, which is the degree of control exerted by the emotion. This data, right here, pulled from the NRC Valence, Arousal, and Dominance lexicon, brilliantly illustrates how that 3D mapping works in practice. Take a word like vacation. It scores a huge 0.840 on valence, or pleasantness, but a pretty moderate 0.412 on arousal. It's nice, but it's relaxing. But then look at the word enraged. It scores incredibly low on pleasantness, obviously, but its arousal, that raw energy level, is nearly maxed out at 0.962. And check out the dominant scores. The word powerful scores almost a perfect 1, whereas a word like torture strips away almost all sense of control, coming in at 0.045. By turning words into exact coordinates like this, computers can literally calculate the emotional distance between our words.
Which brings us to Section 3, teaching machines to feel. So now that we've got the basic vocabulary down, how in the world do we actually get the machines to build these complex word lists automatically? Because we definitely don't want to hand label thousands and thousands of words. Well, we use semi-supervised methods, like this algorithm called SentProp. You can think of it kind of like teaching a child through word association. Step 1, the computer builds a massive weighted graph that connects words based on how similar their embeddings are. Step 2, we just plant a few seed words, like good and bad. Step 3, the algorithm goes on these random walks through the graph, starting at those seeds and jumping to related words. And finally, Step 4, it mathematically figures out which words belong together based on how often that random walk lands on them. So if the algorithm walks from good and keeps landing on delightful and excellent, it quickly figures out, hey, I should probably score these words positively too. Let's shift gears to Section 4, learning from star ratings.
For machines to really grasp nuance, they need real-world grounding. And luckily, the web provides millions of consumer reviews with the absolute perfect supervision signal: star ratings. When we map words against these review scores, like on a 1 to 10 star scale, using what are known as POTS diagrams, we can actually visualize the invisible emotional weight of our vocabulary. It's fascinating. Extremely polarized words like terrible or excellent form this sharp J shape or reverse J shape. They peak heavily right at the absolute 1 star or 10 star extremes. But the more mildly polarized words, stuff like good or disappointing, they form more of a hump shape on the diagram. They peak somewhere right in the middle. Because, disappointing is definitely bad, but it's not a 1-star word. It's more like a 3 or 4-star word. This is exactly how the machine learns that words have entirely different magnitudes of intensity. To put this into perspective, when researchers unleashed advanced statistical methods on nearly 1 million Yelp reviews, they found some wild differences between 1-star and 5-star vocabularies. I mean, sure, obviously 1-star reviews are going to use words like worst and rude, and 5-star reviews will use delicious and amazing. But if you look deeper, it gets really interesting. 1-star reviews heavily rely on logical negation, words like no and not, and they obsess over people and time. They complain about the manager, the waitress, the bill, and waiting for minutes. 5-star reviews, on the other hand, are full of emphatics like very, highly, and absolutely, and they sing the praises of the atmosphere, the wine, and the dessert. By analyzing these specific distributions, the machine learns to decode the exact context of human frustration versus human delight. Now for our final stop, Section 5, the nuance of connotation. Modern AI has evolved way past just spotting good and bad words. It can actually understand complex social dynamics, agency, and power structures, all through what are called connotation frames. These frames show us how just a single verb can reveal an entire power dynamic to a machine. For example, if I write, "The teenagers survived the bombing," the verb survive automatically signals to the machine that the event was a hardship, and the subject, the teenager, is the sympathetic victim. The machine learns that both the writer and the reader likely feel positive sentiment toward that subject. But if I write, "Country A violated country B," the verb violate completely flips the script. Now the machine understands that the direct object, country B, is the sympathetic victim, and the subject, country A, is the antagonist. The verb itself encodes who has power, who has agency, and who we're actually supposed to be rooting for. It's incredibly powerful stuff. And as we wrap up this explainer, we're left staring down a massive question that pushes way past the boundaries of linguistics and straight into the future of our relationship with artificial intelligence. We started this whole conversation with Maya Angelou predicting that someday we would be able to measure the power of words. Well, through dimensional lexicons, POTS diagrams, and connotation frames, machines can now absolutely, mathematically measure that power. They can read our anger, our joy, our shifting moods, and our interpersonal stances. They know exactly who the victim is and who the antagonist is just by looking at the verbs we choose. So the ultimate question is this: if machines can now perfectly measure the power of our words, what exactly are they going to do with that power? Thanks so much for joining us for this explainer, and keep asking questions.